Number 45 is clearly going to be a quotient rule. One thing I looked at here is if we could factor, because I knew the denominator factored, but it doesn't look like the numerator does. So we're going to have to find the derivative by using the quotient rule. Recall that when you're doing the quotient rule, the first thing that you do is take the denominator and square it, and then you bring that denominator up. That denominator is multiplied by the derivative of the numerator, which in this case would be 2x plus 1 plus 0. Oh, let me get that out of the way. There we go. So that's 2x plus 1 minus, take the derivative of the denominator, which would be just 2x, keep in mind the derivative of negative 1 is 0, times the numerator, which is x squared plus x minus 1. And then we would want to clean this up a little bit. The denominator is x squared minus 1, the quantity squared. As I'm looking at the numerator, oh, I'm in the middle of doing a video. When I'm done, dear, I would multiply this out. So the first binomial gives us a 2x cubed plus x squared minus 2x minus 1. And then the second one here is going to give us a negative, because there's a negative right here, negative 2x cubed. And then a negative 2x times x is negative 2x squared. And then a negative 2x times negative 1 is a plus 2x. And then we go hunting for terms we can cancel, like these two and these two. And that leaves us with a, let's see, this term and this term go together. That would give us a negative x squared minus 1 all over x squared minus 1, the quantity squared. I think in the answer key on the back they factored the negative out. Now this is f prime of x. Let's suppose the problem had asked us to find the instantaneous rate of change of the function at x equals, say, 2. Then we would plug in 2 right here and get negative 2 squared minus 1 over the quantity 2 squared minus 1 squared, which would give us, let's see, negative 4 minus 1 is negative 5 over 4 minus 1 is 3 squared is 9. Okay. The problem asked us if the function is increasing or decreasing at 2. We would say it is decreasing because f prime of 2 is less than 0.